We are Team 3, the chart. Last week, we talked about structure characteristic. The chart is consisting of 4 uses. Due to span and small construction area, the chart is divided to 3 materials. And these materials have their own issues. Today, we will talk about construction method about the chart. In the chart construction, there are 2 points. First is time. The chart had to be constructed until 2012 London Olympic. But the chart construction started at 2009 due to global financial crisis. So, the chart has 3 years time limit. 4,000 workers, equipment, and materials must be transported 24 hours a day in unfinished building. As increasing workers, waste of time is bigger. So, to decrease time waste, getting building workers, materials, and equipment to right place at the right time is very important. Second is wind. By the sim scale simulation, the chart receives a lot of wind. This can affect construction. To prevent wind from affecting construction, the chart engineers check the wind speed every day. Because of these 2 points, there are some problems in crane and external hoist. Crane can be collapsed, or the materials in transportation may be fall due to the strong wind. And the external hoist was too slow, and it is located outside of the building, affected by weather such as wind and rain. To solve these problems, the chart uses slip-on core. Over the core, crane is installed and jump lift is installed below. Crane from the core, named TC1, receives less wind, and it can prevent wind collapse. This crane is attached on the core, so core and TC1 go up together. So it reduces a number of the crane climbing. In road construction, due to low wind and large area, floor crane on the ground are used to construct with TC1. But in high construction, because of TC1 and smaller construct area, there was only one high-rise crane. So they saved time and money to build extra high-rise cranes or extend crane height. Jump lift is an elevator in the core. By using elevator hoistway inside core, so it is not affected by weather and safe. And the lift is permanent elevator, so it is fast. To install jump lift, first, protection deck is attached to freeform, deflecting any object that may fall to the shaft. Next, the installation platform is used to install the guide rails and other elevator shaft components. Next, mobile machine room, which controls lift, jumps as the building work progresses. Then, permanent elevator, which will be used after construction, moves below machine room to transport workers, materials, and equipment. Using this system, transportation time becomes down, so construction is finished faster and cost decreases. This method are connected to three-form core, so these are extended until core elevation was over to 66 floors. By using these two methods and existing methods, the composite and concrete floor work is operated. In composite floor, they installed steel column and beams. Steel embedded plate is on the beam to support concrete slab, and concrete was poured. In pre-tension concrete floor, to prevent wind during construction of floor, constructors installed 3 meters windwall first. Next, steel cage is installed and concrete poured, so column is made. Next, floor concrete is poured. It took 20 hours to harden enough. Each floor is finished in 6-day cycle and process started again. In stage fire to install module on the core, the crane on the core had to be removed. So, by using TC1, tower crane TC7 was installed on the 15.5 levels beside the core to replace the TC1. TC7 constructed the spiral level, but assembling the module has 3 challenging constraints. First, construction progress at the winter period. Cold weather and short daytime disrupt the construction. Second, small space at the spiral level due to tapered form of the shaft. Small space can allow many workers and materials, which limits the speed of construction. Last, the wind blow. This affected to the crane movement, which used to assemble the module. Due to these 3 reasons, the construction team had to find methods to minimize the assembling process at the spiral level for the safety and speed of the construction. First, they practice the assembling progress at the ground level before they work at the spiral level. By doing this, they can reduce the trial and error at the spiral level, which can increase construction period. Second, each module has a self-stable structure. Self-stable module can be moved to the spiral level without bracing, which means they didn't need extra work before connecting each modules. With this approach, they can minimize the risky progress at the spiral level and complete the construction safe. The steps of the crane's recovery process are essential. The crane recovery process at the Charles building goes through this process. First, adjusting the tie and roll the crane. When descending this crane, it goes down on each one through hydraulic pressure to the 72th floor. Next, remove T7 through recovery crane. Finally, remove recovery crane via spider crane. Finally, the components of the spider crane and the recovery crane are lowered to the ground via hoist. By the end of the crane recovery process, construction of the shaft is completed. This time, we talk about construction method of the shaft. Next week, we will introduce about building efficiency of the shaft. Thanks for listening. We are Team 3, the shaft.